I'm Kalaimathy Gunalan from RY41. Now I'm going to present about my CAA 2 for PGT 101, which contain one question from topic inductance and capacitance. For this CAA 2, I have used PowerPoint to present my calculation and Tinkercad to stimulate my circuit. Thank you.
Okay, from the question, we have to find out the value of voltage across the capacitance, current across the inductance, and the energy stored in capacitor and inductor. So, to find out the value of RCL is depend on our matrix number. So, based on my matrix number, I got the R9, C is equals to 5, and L is equals to 7. I have redrawn the circuit here. So my R2 will be 9, L is equals to 7, and capacitance is equals to 5. Depend on the DC condition, the capacitance will be an open circuit and the inductance will act as a short circuit. So I have redrawn the circuit. Okay, over here the L is now short circuit and the C over here is now as an open circuit. So to be more precise, I have redrawn the circuit. Okay, from here we can see there is no current or voltage flows over here. So I'm going to take out this part. So after we take out this part, from here we can see that VC is equals to voltage across the R2 and the IL is equals to I total. For VC, I have used voltage divider rule because both the resistors are in a series connection. So we have to find out the voltage across R2, which is equals to VC. So I have used voltage divider rule. R2 divided by R1 plus R2 times with total voltage. So I have replaced all the values. 9 R2 value is 9, so R1 value is 1. So after replace all the values, I got 10.8 voltage. For the I is now is equals to I total because there is no other way to current flow. So I have used Ohm's law, which is equals to I equals to V total divided by R total. Our V total is 12 volt and R total is equals to 1 plus 9, 10, and the I total and IL will be 1.2 ampere. For energy in capacitance, the formula is 1 over 2 times with capacitance times with voltage across the capacitor power of 2. So which we already found this VC. So I'm going to replace all the values. After replace the value, we got 1 over 2 times with 5 times with 10.8, which I already got from the earlier slide, power of 2. So after we calculate this equation, we get 291.6 joule. Okay, the energy in inductance, the formula is almost same, but we have to replace this capacitance with the inductance. So the formula is 1 over 2 times with inductance times with current across the inductor power of 2. And after replace the values, I got an equation there 1 over 2 times with 7 times with 1.2 power of 2, which we got from the earlier calculation, and then this equation is equals to 5.04 joule. For stimulate the circuit, I'm going to use the Tinkercad software. Create new circuit. Okay, first I'm going to choose all my components. First, I'm going to place a breadboard in the middle. Then in the circuit we have two resistors, 1, 2, then one capacitor, one inductor, okay, and other than these components we have power supply, so DC power supply, okay, and then multimeter. We use two multimeters to measure VC and IL. Okay. Now these are the components we're going to use. I'm going to place the components on the breadboard and build the circuit. So first I choose one of the resistors and rotate them. Okay. And then place the resistor over here. Okay, the second resistor is series to the first resistor, so connection will place here, so the connection in between two resistors are in series, and the inductor also series connection. Inductor connection is series with this resistor, so I'm going to place it like this. And then for the capacitor is parallel to the second resistor and the inductor. So take a wire and then place it like this. Okay, and I'm gonna change the voltage into 12 power supply and then current into 2, and the positive terminal over the first resistor. Okay. And then the negative terminal into inductor. Okay. Now the circuit, I'm gonna change all the values. The first resistor will be 1 ohm, and then the second resistor is 9 ohm. Okay, and the inductor value is 7 Henry. The capacitor is 5 farad, so 5 farad. Okay, now these are the circuit. For measure the VC, voltage over the capacitor, and IL, current over the inductor, I'm going to place a voltmeter which is parallel to this C capacitor, and then ammeter to measure the IL over the inductor. So got to I'm going to place the voltmeter over here. It's already in a voltage mode. Okay, negative terminal, place it over here. Okay, and the positive terminal. Okay, then we're going to use this multimeter as a ammeter. I'm going to rotate. Okay, for this ammeter, I'm going to connect into series with these two resistor with the inductor. So I'm going to move the red inductor a bit further. This should be like this, and then the power supply. Okay, then this is our ammeter. negative should go here, so over here, and then the positive is going to be here. Okay, now we have placed all the components. For measure the VC, I have put a voltmeter over here, and IL I have placed a ammeter over here, and then we have a power supply which is 12 volt and 2 current, 2 ampere. Okay, I'm going to simulate the circuit. Okay, as you can see, the voltage is reached our 12 volt, and then the current is now 1.21 ampere. Okay, the reading for the V across the capacitor is 10.5 volt, and the current across the inductor is 1.2 ampere. Okay, now we're gonna see the results from the measured and calculated values for VC and IL. For VC, voltage across the capacitance, the calculated value is 10.8 and the measured value is 10.8. And for current across the inductance, the calculated value is 1.2 and the measured value is 1.2. From this table, we can see the calculated value and measured value are both are same. And for energy in capacitance, from the calculation, we got 291.6 joule, and the energy in inductor, from the calculation we find out that 5.04 joule. Okay, that's all for the CAA 2 from me, and thank you.